Welcome back, everyone. Today I'll be doing complex number. It is the CAPE Unit 2 2017 Paper 2 and it is 1C. I did the differentiation aspect, which is 1B. Now I'll be looking at the complex number aspect. Let's get started. Find the complex numbers u equal x plus iy such that x and y are real and u square equal negative 15 plus 8i. Given this information, I know that I have u is equal to x plus iy, but also u square is equal to minus 15 plus 8i. So let me write this. Now, u is x plus iy, so I replace u square. So I'll have x plus iy all square is equal to minus 15, which is representing the real, plus 8i, which is the imaginary part. Now I am going to expand x plus iy all square. All square means I am repeating the bracket twice. So it means I have x plus iy times x plus iy. Now, having this, it means I will be expanding. So x times x, that gives me x squared. Then x times iy, you can say xiy, or I'm going to write xyi, but you could also have yxi. The order doesn't matter, but I prefer to have x and y, which is representing the real, in front of I. And so iy times x, that will give me xyi. Iy times iy, that's going to give me I square y square, because y times y give me y square. Now I square is negative 1, so this is going to change to minus. So the x square minus y square, because I'm grouping the real together. So x square minus y square, and then xyi plus xyi will give me 2xyi. So this is the expansion that I'm going to replace on the left. So I'll have x squared minus y squared plus 2xyi is equal to minus 15 plus 8i. Now, x squared minus y squared is a real. I'll equate it to be equal to negative 15. So I'm equating the real to be equal to the real. So x squared minus y squared is equal to negative 15. And then my imaginary 2xy is equal to 8. So here I have simultaneous equation. And for the second one that I have 2xy equal 8, I am going to make x be the subject. But before I do that, I divide both sides by 2, reducing this to get xy equal 4, and I label this as equation 1 and equation 2. And now to divide both sides by y, and I have x being the subject, so x is equal to 4 over y, and I'm going to call this equation 3. So I'll be substituting equation 3 into equation 1. So where I have x squared, it will be replaced with 4 over y. So what I have here is 4 over y all square. So 4 over y all square minus y square equal minus 15. Now to continue, I square the numerator and denominator, so I have 16y squared minus y squared equal negative 15. I need to get rid of the y squared in the denominator, so I'm going to multiply both sides by y squared. So multiplying both sides by y squared, the y squared is going to cancel here, so I'm just left with 16. And then y squared times minus y squared, that's minus y to the 4. And then have my equal sign. So I have minus 15y squared. So carrying this over the equal sign, I'll just have equal 0 here. And then I'll have positive y to the 4 minus 15y squared. So the plus 16 carry over to get minus 16. So it's a positive 16 become negative. Now factorizing, just like how you factorized before, two numbers that multiply to give me negative 16, but add to give me the center, which is minus 15. So to think about this, it must be minus 16 and positive 1. So it's multiply to give me negative 16, but add to give me minus 15. And these two numbers are minus 16 and positive 1. Now I am going to replace the center. So I have y to the 4th minus 16y squared, followed by having plus 1y squared minus 16. Just remember, when you add, you're going to get the center. So adding this, I will get minus 15y squared. Now grouping to factor out what is common, we're going to factor out y squared, and I'm left with y squared minus 16. And then the next one, I factor out positive 1. So I'm left with y squared minus 16. So it means I have y squared plus 1 and y squared minus 16. Now don't forget equals 0. So that's what I'm going to move on to. I'm going to solve where I equate it equals 0. Don't forget x and y are real. So I have y squared plus 1 equals 0. Solving for this, I carry it over, it becomes minus 1. So I have y squared equal negative 1. Now to get rid of square, we have to square root both sides. But looking at this, it's going to be an imaginary number. And it's stated that x and y, it has to be real. So we cannot use this. So the next one is y squared minus 16 equal 0. So we carry the minus 16 over the equal sign to get positive 16. So I have to square root both sides. So y is equal to plus or minus 4. So that's plus or minus 4. After doing this, I can find out what is x because I have x is 4 over y. We can use that. X is equal to 4 over y from equation 3. So using this information to find out what is x, let me go ahead and write that. So x is equal to, I will substitute for y when y is equal to positive 4. So it's 4 over 4, so x is equal to positive 1. And then we have when y is equal to negative 4. That's supposed to be y is equal to negative 4. I'll have x is equal to 4 over negative 4. So working this out, I will have x equal negative 1. So what does that mean? Remember, u is equal to x plus yi. So substituting what I have here, x is plus or minus 1 because we have a positive 1 and negative 1, and y is also plus or minus 4, positive 4 and negative 4. So it means I can factor out the plus or minus to get 1 plus 4i, and this represents u. Hence, or otherwise, solve the equation z squared minus 3 plus 2i times z plus 5 plus I equals 0 for z. So to solve this, I am going to use the formula minus b plus or minus the square root of b squared minus 4ac all over 2a. Let's get started. Now, given that we know once I cannot factorize, I have to use this formula. I am going to identify what is A, B, and C in this equation that is given for me to solve. A is a coefficient of z squared, so A in this case is 1. B is a coefficient of z, so that is minus, open bracket, 3 plus 2i. And then C is 5 plus I. So substituting, I'm going to have minus, but minus 3 plus 2i. So I'm hoping you're seeing that the negatives will cancel. Plus or minus the square root of b squared, so that's minus 3 plus 2i being all square, minus 4, a is 1, and c is 5 plus I, all over, let's extend this, all over 2 times a, so that's 2 times 1. This is a time to simplify, so this is going to be positive, so I'll have 3 plus 2i, and within, where I have the square root, I have underneath the square root, within the bracket where I have all square, really and truly the negative is going to turn to positive. But I have 3 plus 2i all square. It means I'm going to expand this twice. So I have 3 plus 2i times 3 plus 2i. So expanding this, I have 3 times 3, that's 9. 3 times 2i, that is 6i. 2i times 3, that's 6i. And 2i times 2i, that is plus 4i squared. I squared is negative 1, so that means I have 9 plus, that's 6i plus 6i, that's 12i. And this will become minus 4. So 9 minus 4, that's 5. So I have 5 plus 12i. And here, this is going to be 5 plus 12i. 4 times 1 is 4. So minus 4 times 5, that's minus 20. And minus 4 times I, that's minus 4i. All over 2 times 1, that's 2. Now, underneath the square root, I can simplify. So let me just rewrite the 3 plus 2i plus or minus, and simplifying underneath my square root, plus or minus square root of 5 minus 20, that is negative 15, and 12i minus 4i, that's positive 8i, all over 2. Now this looks familiar. I have minus 15 plus 8i. It's coming from part 1. Let's look at part 1. Now, u squared is equal to minus 15 plus 8i. So if I square root both sides, that's going to give me u equal the root of negative 15 plus 8i. That's what we have on the page here. So it means that this represents u, and u, remember, I just found out that u is plus or minus 1 plus 4i. So I can replace the square root to be 3 plus 2i plus or minus 1 plus 4i all over 2. And now I will separate. So I will have 3 plus 2i minus 1 plus 4i. And I'll put the 1 plus 4i in bracket because the minus sign will affect it. All over 2. Also, I will have 3 plus 2i plus 1 plus 4i all over 2. Now, what's left is just to simplify. I have 3 take away 1, that's real to give me 2, and 2i minus 4i, that's minus 2i all over 2. Simplify, 2 can go into this, so I have 1 minus 1i, or I. And then 3 plus 1, that's 4. 2i plus 4i, that's 6i. All over 2, I can reduce this to get 2 plus 3i. And that is the answer. Thanks for watching, guys. Don't forget to like and subscribe to my channel.